Okay, so we're learning about sampling distribution models. A sampling distribution model is how a sample proportion varies from sample to sample. What we need to know is the sample area variability and the central limit theorem. Sampling area / variability is variability seen from one sample to another, and the central limit theorem is if the sample size is large enough, the sample distribution of the mean will become normal or nearly normal. There are two kinds of sampling distribution models. There's proportions and then there's means. Proportions use percentages and like fractions and those sort of things. And what we need from those is a simple proportion, which is p hat, and then the simple mean, which is x hat. We have assumptions and conditions for those, which is the sample values are independent, the sample size is large enough, the sample subjects are randomly assigned, the n is no larger than 10% of the population, and there are at least 10 successes and 10 failures. In order to find out most of the questions for these kinds of problems, is we need to know the mean, which is p hat equals p, which is the proportion, and then the standard deviation, which is the standard deviation p hat, is pq over the square root of pq over n. A sample problem would go somewhat like this. A national survey revealed that 44% of Americans have naturally brown hair. A statistics professor decided to test this and discovered that 96 out of his 244 students have naturally brown hair. Should he be surprised at this result? Explain. Now, I already did the conditions for us. So the samples are independent, and sample size is large enough as it's 244 students. The subjects are somewhat randomly assigned, as their students are not actually randomly assigned, but it's okay because we know that. 244 is less than 20% of all students, which is all the population, and 44% of 244 is 107.736, which is greater than 10%, and then 56% Q is of 244 is 136.64, which is also greater than 10. Now, in order to solve this problem, we need to know the n, 244, the p, which is 44%, or 0.44, the q, which is 0.56, and then the p hat, which is 96 out of 244, which is also 0.3934. And now we use these to find out the mean of p hat, which is p, which is 0.44, and then the standard deviation, which is 0.44 times 0.56 over 244, all square rooted, which equals 0.0317. And now we make a normal variability chart, which is this thing. The mean is 0.44. Standard deviation is 0.0317, and the value we're looking at is 0.3934, and we're looking for less than. Now we need to find the z value of all of this, which is 0.3934 minus 0.44 over the standard deviation, which is 0.0317, and that equals negative 1.47, which is our z value. And we use this to figure out whether or not he should be surprised at his results. And you shouldn't, because it makes sense, as it's within the naturally, which is within one standard deviation of the mean, which means his students are a good example of the national average of brown hair, which is what we write. Okay. Now, the other kind of problem we use are mean problems. Those use averages and numbers, not really more percentages than anything else. The only variable we really need to know is y hat, which is the sample mean. Our conditions we need to know, though, are sample values are independent, n is large enough, subjects are randomly assigned, and sample size is smaller than 10% of the population, and then the last one is different from the population, which is for proportions, which is that n is relatively large enough. We also need to know the sample distribution model for means, which is the mean of y line which is the mean, and the standard deviation is the standard deviation over the square root of n. A sample problem would be college reported national test scores with an average of 2.85 and a standard deviation of 1.33 for the AP Stats test. An AP Statistics teacher has 63 students preparing to take the AP exam. Though they were obviously not a random sample, he considered the students to be typical of all the national students. What's the probability that his students will achieve an average score of at least 3? I already wrote down the conditions and assumptions, so we can learn them. It's good. The only thing that's really kind of odd is that these subjects are not random; they're students, but it's okay because we already know that. Now we need to find the n, the mean, and then the standard deviation, which is 63, 2.85, and 1.33. Now we use those values to find the mean, which is 2.85, as it's the same, and the standard deviation, which is 1.33 over the square root of 63, which is 0.1675. We use that to make a normal model with a mean of 2.85, a standard deviation of 0.1675, and our known value of 3. And find our z-value using those values, which is 3 minus 2.85 over 0.1675, which is 0.8955. And we're looking for the probability that a student achieve an average score of 3 or more. So we use the normal CDF, which is 0.8955, a very large number, 1,000, 0, 1, which is 0.1852. So the students have an 18.52% chance of getting a 3 or higher on the exam. And that's all we really need to know for sampling distribution models. Thank you.